Hi, my name is Sathya. I'm a PhD postdoc fellow in Dr. Kiran Smalley's team in Moffitt Cancer Center. So today we are at AACR 2023 at Orlando. Here is my poster. So the main objective of the work is to study how the uvel melanoma leads to the liver metastasis. So the main goal that we are trying to see is how this uvel melanoma and liver cells crosstalk leads to the metastasis. So here, first to understand, the more than 1 in 2 patient leads to the liver metastasis after the removal of primary cancer in the eye. So to do that, first we developed a liver metastasis model. So here we used a uvel melanoma cells and Tylway inject in the mouse, and they develop 100% of mice develop the liver mets. Here is a vehicle, and then we treated with a MEK inhibitor called trametinib, because MEK inhibitor is already approved, FDA approved in the cutaneous melanoma, and also GNAQ is the main mutation in uvel melanoma that leads to the activation of MAP kinase. And also we also saw that when there is an activation of MAP kinase, when you treat them with trametinib, we saw that there is an increase in HDACs. So therefore we use a pan-HDAC inhibitor, and then we saw that there is a combination led to the smaller liver mets. And surprisingly, when we did a single cell RNA sequencing, since the tumors they were small, but there was a tumor. So we saw that there are plenty of stellate cells. Since stellate cell job is to store the vitamin D, and these are like in a normal state. But when there is a cancer cells, they will activate stellate cells, and that stellate cells release the ECM factor. So you saw that you can see that there is a majority of cells stellate cells, and when you do the combination therapy, we saw that there is presence of stellate cells decrease the efficiency of HDAC and MEK. And then, therefore, to understand this, we did a single cell RNA sequencing both in vivo and in vitro. In vivo, we can see that there is an interaction between uveal melanoma and other fibroblast-like cells. So, when we saw that single cell RNA sequencing showed that there is an interaction through FGF2 coming from melanocytes and to the uveal cells that leads to the cross communication. Therefore, so we saw that there is a changes in heterogeneity of presence of hepatic stellate cells that leads to the more towards the migration, invasion, metastasis on angiogenesis. And clearly there was an increase in the STAT3, FOG, JUN-D and GDF15. So GDF15 is involved in the metastasis. Therefore, we checked in the clinical samples from the Dr. Orvo's lab from Miami, and then we saw that there is a class 2 patient at a higher GDF15. So this is interesting because class 2 are the ones will lead to the 70% of chances of going to the liver metastasis. Then we saw that adding a GDF15 on hepatic stellate cells, these are quiescent cells. When you add GDF15 on them exogenously, there is an activation and secretion of collagen 1, which is the ECM marker. So that shows that GDF15 is activating stellate cells, that is helping the uveal melanoma growth through secretion of many pro-angiogenic factor release, such as COL1, MAP, MMP2, VEGF, CTGF, etc. And also we saw that co-culture also had a fibronectin which is involved in the angiogenesis. And we saw that when we did the co-culture of hepatic stellate cells and uveal melanoma, we saw that there is an increase in IL-8. IL-8 is involved in angiogenesis. As you can see in the monoculture, there is nothing, but also in the hepatic stellate cells, they don't express, but when they come together, there is a secretion of IL-8. So that we are confirmed with the ELISA. And here you can see that in co-culture, there is an co-culture had a higher IL-8, and in monoculture, there is not. You can also see here. So since there is many of these factors are leading us towards angiogenesis, we saw that adding GDF15 and IL-8 come together has increased the tube formation on endothelial cells, UX cells. And you can see that number of network formed in the well, you can see that combination had a higher network formed. But when you add, when you inhibit either with IL-8 or HDAC MEK, there is a disruption of tube formation in the UX cells. So finally, we went back to our liver mouse model, and we saw that CD31, which is the vascular endothelial vessel formation, was decreased when you add them MEK and HDAC. And also, interestingly, HDAC and MEK also can decrease the GDF15, which is the main factor which is coming from uvel cells. So this together shows that how uveal melanoma from the eye leads to the metastasis. The interaction or by communication between uvel cells and the hepatic stellate cells gives the nice ECM factors that is helping the uveal melanoma cells for growth, which can be reduced or inhibited through using HDAC and MEK inhibitor. Thank you.